The inclined plane. Previously, we dealt with horizontal surfaces. In that case, normal force and mg were always along the y-axis and were equal, and there was no acceleration along that axis. So now we're going to look at a surface that is not horizontal. This non-horizontal surface will be called the inclined plane. So let's draw a free body diagram. We've got mg down and normal force perpendicular to the surface. Remember that normal force is always perpendicular to the surface and mg is always directed downward, but now they are neither parallel nor perpendicular to one another. Previously, we used horizontal and vertical axes. That worked because problems always resulted in an acceleration that was along one of those axes. But for the inclined plane, the acceleration is not horizontal or vertical. It will slide up or down the incline without losing contact with the surface. Since the acceleration can only be along the incline, we need to rotate our axes so that the x-axis is also along the incline, and the y-axis is perpendicular to the incline. Another reason to rotate the axes is because of friction. Friction will be along the x-axis, so the only thing that is not along an axis is mg. So now by rotating the system, we only need to resolve one force, mg, into its x and y components. Now let's assume that we didn't rotate the axis. How many forces would we have to resolve into components? If we kept the axes the same, we would have to resolve the force of friction, the normal force, the force applied, and the acceleration into components.